The diagram shows a wedge, all of whose faces are smooth, resting on a smooth horizontal table. Its faces make an angle A and B. Tan A is 4/3 and tan B is 3/4. So my opposites are the 3 and the 4, so tan A. So let's look at cos A and sin A. Sin A is O/H, which is the 4 over what's going to be 5, so cos A is 3/5. And cos B and sin B are the opposite, 4/5 and 3/5. The wedges are mass M, and the particles are mass M and the wedge is mass 2M. So what forces are at play here? So I have my 2mg, and the reaction between the wedge and the table doesn't come into the question, but we'll call it S. My particle of M has a reaction between itself and the wedge in opposing directions. It has mg coming straight down, and I'll just take this guy out so I can, well actually I'll do it in the next diagram. I'll leave that there. I have my angle A, my angle B. My second wedge is going to have a reaction to R2, actually R1. We call it R1 and R2. Why not R1 and R2? Mg and R2 coming down. Okay, so there are my forces. Let's have a look at the first particle on the left here. Mg. So coming straight down, adjacent to A is mg cos A, which is mg by 3/5, and down the slope I have mg times 4/5. My acceleration, I didn't put my accelerations in actually. I'll go, because we 3, I'll just go A, B and C. A, B, actually I'll call the wedge, we normally call the wedge A. I'll go A for the wedge first, and then the particles are B and C. So the acceleration of this particle coming down the slope has an acceleration of B, and the acceleration in this direction is an acceleration of A. So if we continue this along, just create a right angle here. We have angle A corresponding in here. So along this line here in this direction, we're going to have adjacent to A. What was the cos part? 3/5. So we're going to have, this is A, we're going to have 3A/5 on this side and 4A/5 on this side. So B minus 3A/5 is my acceleration, and if we, I forgot to put my R in, if we put my forces going down this way, I can create my equation. This is my 4mg/5. This guy here is the only one going down. There's nothing going back, so that's equal to ma, m times my acceleration, b minus 3a/5. So I've got an equation going down the slope. If we think about perpendicular to the slope, we're coming down first because we're not jumping up in the air. So I have 3mg/5 minus r in the other direction is equal to m, and the perpendicular acceleration was this one over here, this 4a/5. Okay, that's particle 1. Let's look at particle 2. So it's coming down the slope. I find it really hard to do the diagrams on the other side for some reason. Mg, R2, actually I think we called the last one R, then we should have called it R1. So I've got my angle B. So inside the triangle, I'm going to have, coming straight down as adjacent, so I'm going to have mg cos B 4/5. So mg cos b 4mg over 5 in that direction, and down the slope in this direction is going to be 3mg over 5. We call this acceleration c, and it's also moving. So we need to know what's going on back that way. So we have c going down. If I create my diagram, I can say, well, angle B is in here. So it would also be in here if we draw a line out like that. So that's my acceleration A. That's my angle B. And if I do a right angle triangle, I can say on this side here, it's adjacent to B. The cos of B was 4/5. So over this side I have 4a over 5 adjacent, and on this side 3a over 5. So my acceleration going down in that direction is going to be c plus 4a over 5, because they're both going to the right. So my equation of motion in this direction, my 3mg over 5, there's nothing opposing it, is equal to m, which is just m times a, which is c plus 4a over 5. And perpendicular to the slope, I have 4mg over 5 minus R2 is equal to m, and perpendicular to the slope, my acceleration was 3a over 5. And that's my second equation. And I've just seen a mistake here. I should have started with my R2 and do the direction. So it's actually R2 minus my 4mg over 5 is equal to my MA. Just be careful. So I have two equations here. And I have equations from above, and now what I need to do, I just need to get an equation for the wedge. And let's see where that brings us. So here's my wedge. With the wedge, what weight was the wedge? Or what mass was the wedge? Mass with the wedge was 2m. And we also have 2m sitting on top of it. So I need to get my reactions. I've got 4mg coming down there, but I'll just do 2mg. I'll just focus on the wedge itself. And I've got these reactions that I need to resolve, my R1 and R2. So R1 is coming straight down this way. I'll do them separately. I'll do them on different diagrams. That's R1. So we want acceleration is in this direction. So we need to know what's going on in this way for R1. And going back that way for R2. So we need R1 and R2. And then we might be able to sub them back in and we see what happens. So we've got R1, so coming straight down. Got my angle A. And straight across. So got my angle A. Just double check what the cos of A was. Cos of A was 3 over 5. So on this side we have 3 over 5, 3 over 5. And coming down here we have 4 over 5, or M and A. And then if I just do the other particle on the other side, M, we call it R2. So coming down this way is R2. And we're looking for, I've got my angle B, So opposite B is the one we're looking for. So sine of B, just double check, sine of B. There we go, sine of B 3 over 5. So over this side we have 3 over 5. 3 over 5 of R2. And on this side here we have 4 over 5 of R2. So my equations here, we have it's going in this direction with an acceleration A. So we have 4/5 or 1, we call it 4/5 of R1. And in the other direction, it is 3/5 of R2 is equal to m, which is 2m times acceleration, which is a. Now, what we need to do is, if we can sub R1 and R2 in, we do need to show that acceleration is 0. So let's get R1 and R2. Let's get R1 first from up above. So we don't need this one, I don't think. So R1 is equal to 3mg over 5 plus 4ma over 5. 3mg over 5 plus 4ma over 5. 3mg over 5 plus 4ma over 5 is R1, and we'd have to multiply that by 4/5 minus 3/5 times R2. R2 to minus, so R2 is equal to 4mg over 5 plus 3ma over 5. 4mg over 5 plus 3ma over 5 is that, and that's equal to 2ma. Let me double check. 4/5. I make a mistake of the sign here. Yeah, this is going to be a minus. If I bring R1 over positive, this is going to be negative 4ma. Just be careful. Minus 4ma, that R1. Just looking at needed a negative in there. Negative. Okay, so what can I do here? I can multiply across by 5. That's the easiest thing to do, I think. If I multiply everything, well, actually it's 25. I'll do it in 2 steps. 12mg over 25 minus 16ma over 25 minus 12mg over 25 minus 9ma over 25 equals 2ma. 12mg over 25 minus 12mg over 25, they cancel. And we're left with minus 25 ma over 25. So for minus ma to be equal to, this becomes minus ma to ma, a would have to be equal to 0, which is what they're looking for here. Or you could divide it by a, and you could say by m minus a is equal to 2a. You could say 3a is equal to 0, so a is equal to 0 as well. Whatever way you want to solve it down, but a is 0 in this case.